Welcome back to the video lecture series for Introduction to Data Programming using Scala. This is hopefully now really our last video in the network game example. It's our third video since we have started switching things over to normal socketing instead of RMI, and we left off in the last video with this little problem that the code all seems to be in place and it should work, but the server was never getting these messages. The client was sending them. We were able to put print statements in here and see that indeed this code was happening. It flushes the objects they're going across. So in between I played with this a little bit more, and it turns out if we don't check for the is available, the messages really are coming. But the problem is, as long as we're calling read players inside of the main thread, or inside of the main thread here, it has to check for is available because it's not allowed to block. And if we don't do that, the read object is going to block. So that leads to a bit of a problem. This call is not working for the object input stream. I don't remember ever having this problem in the past, but I also can't say that I've explicitly done an is available on an object input stream in the past. So we have to work around this. And as I mentioned in the last video, one way to work around this would be to use multiple threads instead. So instead of having the read player called from the main thread, what I'm going to do is I am going to come here inside of connect where we set up each one of the clients, and I'm going to start something running off in its own thread. Okay. So what's going to happen here is basically an infinite loop where each one of these players is going to do this. Now there isn't any client here. We're inside of the connect, so basically as soon as you connect, each one of the players is going to sit there with their own thread. We no longer need read players. Sit there in their own thread and repeatedly read an object, and if the object they get is turn left, then they call turn left. If the object they get is turn right, they call turn right. And I am going to I'll leave those in there just in case this fix doesn't fix it. So we run the server, we go to the client, run the first client, run the second client, we get our countdown. Now we're going to hope that when I press left and right, indeed, the red bike starts turning. Okay, so that finishes off our example using socketing, normal socketing, instead of using RMI for our application. We now actually do get an exception because of this. So things that we could improve still, and also something that's worth mentioning. So that worked. We didn't really need those. We don't need those print lines anymore. Right now this while true is going to keep going forever and ever. It would be nice to have some way to tell it to stop. We could make it so that the winner was defined at the object level instead of just inside of the start game function, so that this would keep going while winner was less than, in fact that would actually be an easy one to do, winner less than 0, which is exactly what we were checking down here for this loop. But now I will declare winner up here as a private var at the class level or at the object level. One thing that should potentially jump out to you that is worrisome at this point is this is happening in a separate thread. Okay, and we've gone over the case multiple times that when you have multiple threads, you have to start worrying about race conditions. And so now earlier with the while true, I didn't have a race condition here, but now I have this winner thing as a race condition. I also have turn left and turn right calls. And the question is, do any of these matter? Okay, so imagine that that you have this particular call here. What happens if it doesn't quite get the change in winner exactly when it's supposed to? Well, it turns out it doesn't really matter. Okay, it'll just go through one extra time. It might wind up throwing the exception. We probably should use a try catch here so that it doesn't print out. But so instead, when a player disconnects, it just does so silently, and we don't get a message about it. What about these down here? Okay, now these are modifying the clients that are stored and the particular values in them. Should this bother us? Well, it turns out this actually can't be a race condition, because this thread here gets started up once for each client. One of the clients will be player 0 and the other client will be player 1. So player 0's thread is only going to turn left for that player, and player 1's thread is only going to turn left for player 1. Same thing for right. So at least in the sense of getting things from the different players, we don't have any problems here. What about the fact that the players' directions are used in move? Once again here, turns out this isn't really a big deal. That the fact that this is only reading and not writing, if you go 1 pixel before when they hit it, as opposed to they're just, this isn't going to cause your program to be wrong in a way that is going to be noticeable to the user, or really that affects the outcome in any significant way. So fortunately for this case, we really don't need to worry about the race conditions. If you wanted to be extra careful with it, you could synchronize on the different players to make sure that you handled things appropriately. But this works sufficiently for what we have right now, and that's it for this video. We have now written Tron using both RMI and regular socketing, and we'll move on to talking about some data structures.